Hello and welcome to helpyourmath.com. In this video, we are going to take a look at interpreting histograms and ogives. Before we get started, in the last video I did an example where we created a histogram, a relative frequency histogram, and an ogive for a set of data that involved people at work and how much time they spend on social media. So that's what we're going to use in this first example, and just to go back and just review it. This was the information we were given. We created the frequency table with all of the various elements that we would need to create each of the graphs. And then we have our regular histogram, our relative frequency histogram, and our ogive. So the first set of questions will deal with those graphs. So it says, determine which graph to use to answer each of the following questions, and then answer the question. So the first one says, what is the modal class or classes? A modal class is the class or the classes that occur the most frequently. So a mode, that's what occurs the most frequently. So of those three graphs, which one would be the best for determining the mode? Really, you could use either the regular histogram or the frequency histogram, because what we'd be looking for is which bar is the tallest, because each bar is representing the number in that category. In looking at the relative frequency, it's clear that it's that last class, the 60 to 69, and same with the regular histogram. We can very clearly see the modal class is that the midpoint is 64.5. 6 was more common, right? There's 6 is bigger, more people than any of the other classes, so that would be our answer. And I would say we could say either one for this. Here I'll say either histogram would work. However, probably the first one, because then we could actually give the data. So when we say either histogram, and then it's asking for which class, remember the classes are the x-axis, or we want the class, not the midpoint that I used, and that class was 60 to 69. The frequency was 6, that was the most, that's what makes it the mode, but then we refer back to the class that it's associated with to determine which class it was. Next question, what is the probability an employee chosen at random spends between 40 and 49 minutes on social media sites? Because it's asking for probability, we want to use the relative frequency histogram. And then we'll just be able to pull that number right off the y-axis. So we'll check that class, and then we'll check its probability. Okay, so going back, here we are. The relative frequency histogram, we were looking for 40 to 49. That's this one here, and that was 15%. And we'll say 15%. Last up, what is the probability an employee chosen at random spends between 20 and 59 minutes on social media sites? For this one, if we use process of elimination and inductive reasoning, we're going to go with the ogive. How would we use the ogive to help us with this? Well, it's keeping a tally. So 20 to 59. Here's 59 here. We pull up and we see we're at 14. So we know that from this point to the left, there's 14 employees. We know there's a total. We can also use the ogive to tell us the total number here, and the total is 20. And we would say 14 out of 20. And if we convert that to a percent, that would be times 5. Times 5, come on brain, there we go, 70%. So there would be a 70% chance that someone chosen at random, an employee chosen at random, spends somewhere between 20 and 59 minutes, just under an hour on social media websites. Another example, consider a survey of commute times of students to BMCC. First, how many students were surveyed? So looking at this beautiful graph, this is an ogive, this is cumulative frequency. And so to figure out this first question, how many students were surveyed, we go straight to the top, and we would see that there were 100 students surveyed. What is the number of students who have a commute less than 20 minutes? So 20 minutes is right here. Less than 20 minutes would be, we go to this bar and we see 80 have less than a 20-minute commute. What percent of students have a commute time of less than 20 minutes? Oh, what percent? Oh, well, to calculate a percent, we would take the actual number, which was 80, divided by the total. Whoops, because everything's out of 100, this works out nice. It's just 80%. How many students commute between 10 and 20 minutes? So for this one, we're going to look at how many spend 20 minutes. We know that's 80. We're going to look at how many are less than 10, which is 20. And we're going to subtract these values because what we want is we want this here. So we want in between the 80 and 20. And 80 minus 20 gives us 60 minutes. 60 students. Still back on that time question. 60 students. Okay, and the last example. So as always, I forgot to mention this in the last one, so go back in time, hit pause on the video and try these for yourself. I encourage you to do that with this gorgeous histogram here. Okay, so this one we're looking at record high temperatures in various states for all 50 states. We'll notice that this is ever so slightly skewed to the right, right? It's kind of is like a little bit heavy on the 134 point, oh, gross. Okay. What is the lower class limit for the third class? So we're going to count the bars. This is class 1, class 2. Here's class 3. It wants the lower class limit. That would be this right here at 109.5. What is the class width? So a class width, we would take the lower class limit of one class and subtract it by the lower class limit of the one immediately to its left. I would do, let's just do the first two, 104.5 minus 99.5, and I'm getting the class widths are 5 degrees. How many data values are there? Okay, so I'm going to erase my 1, 2, 3 because that's not representative. We go to the graph and we say, okay, is that hitting 3? Oh, it's not, so that's probably 2, right? Because we see that the values are going counting by 3s. Now, the other thing is it's saying for each state, if you know how many states are in the union, then you can probably already answer this question, but let's verify that, we didn't leave a state out. Maybe this was completed in 1946 before Alaska and Hawaii were states. We want to make sure, but probably it's 50. I'm banking on 50. This one here looks like it's going to be 8, not 7. This one up here, does it hit 18? Let me try to get 18. I think that is 18. And then this one, is this 12? Okay, this next one is 13. I did this already and called it 12 and it was wrong. This one's a little bit lower than the 8, so it must be 7. And then those are both 1s. Let's just make sure this really does include every state by adding these up. 2 plus 8 is 10, plus 18 is 28. Plus 13 is 41, plus 7 is 48, plus 1 is 49, plus 1 is 50. So yes, there are in fact all 50 states represented. What is the modal class, the one that occurs the most frequency? So we're looking for the tallest bar on a frequency distribution. The tallest bar is the 18, which means the modal class, 18 is the number of states, but the modal class, we look to the x-axis, would be 109. I'm going to call it 109.6 to 114.5. I don't like, including it in both classes, so I'm going to just change it ever so slightly. What is the relative frequency of the modal class? So the relative frequency, we take the number in that class, which is 18, and divide it by the total, and then we could divide and multiply by 100, and we'll get 36%. So 36% of states had a record high temperature somewhere in between 109.5 and 114.5. Yikes. And then what is the class midpoint of the fourth class? We're just going to have to use the information given on this. So I kind of changed it with my modal class. Really, I would put a 5 back in there. When I calculate the midpoint, I will. So let's see. 1, 2, 3. There's the fourth class. To calculate the class midpoint, we add the lower limit, which we'll do 114.5. plus the upper limit, 119.5, and we'll divide this by 2. This would be 115 plus 120 is 235. I know I added 1 to both of them when I should have only added it to 1. Let's see. Okay, we get 234. So yeah, I added 1 extra 1. And then 234 divided by 2, we're going to get a nice, beautiful 117. So the class, 117 degrees would be the class midpoint of the fourth class. These have been a lot of examples of the different ways we can represent frequencies when we're given data. Thank you for sticking it out with me, and thank you for stopping by.